Hello students, today in this video I am going to cover the topic ramp type DVM. First we have to know why it is named as ramp type DVM. DVM means digital voltmeter. Here the voltage is being measured with the help of ramp signal. That's why it is called the ramp type digital voltmeter. So let's see the block diagram and the voltage to time conversion of the ramp type DVM. So I will explain each block of ramp type DVM. So let's start. So the voltage which we are going to measure is given to the first block, which this is one first block, that is called ranging and attenuator. So the input voltage which we are going to measure is given to the ranging and attenuator. So what is the function of ranging and attenuator? So basically the ranging and attenuator is used when we are applying input voltage. Suppose the input voltage is bigger voltage, the bigger one. The value of the input voltage is very high. So it will give some noise. So to not get the noise, to not disturb the signal, we are applying the attenuator. So which attenuate the extra voltage. And the ranging, which one is called the amplifier stage. The input voltage is being amplified through this ranging, or you can say that is the amplifier. So it can amplify the signals for the better result. Then it is given to the input comparator. So here we can see that the total block diagram, the ramp type DVM, the total block diagram, the heart of the block diagram is your ramp type generator. It is named. So ramp type generator, why? Because the ramp generator is given here, and the ramp signal which is generated from the ramp generator is given to the comparator. We are using two comparators here. One is input comparator and second one is ground comparator. So the signal which is generated from the ramp generator is given to the input comparator and one is given to the ground comparator. So input comparator means what? It compares two voltage level. So one which is coming from the ramp generator and one which is coming from the ranging and attenuator. We can say that the ranging, the input, this is the input voltage which is coming from the ranging and attenuator, which we are going to measure. So there are two voltages, that is one from the ranging and attenuator and the second one is ramp generator. So it will compare the two voltage levels, the input voltage and the ramp generator voltage. So after comparing, so where you can see or you can understand from this voltage to time conversion. So this is my unknown voltage. This is my unknown voltage or the input voltage which we are going to measure. And this is my voltage we are taking, like you can take 24 volt, but I am taking the plus 12 volt. So this is the unknown voltage, this is the unknown ramp voltage. Sorry, this is the known voltage. So here the unknown input voltage and here the ramp voltage. So when the input voltage is equal to the ramp voltage, when the ramp voltage is equal to the input voltage, that means the two input comparator compares the two voltages. When this voltages is equal, then it will give a start pulse. So after getting a start pulse, what will happen? So here you can see that there is an oscillator is connected. So the function of the oscillator is to create or to generate the clock pulses. That is the pulse voltage. So that pulses is generated from the oscillator, that is passed through the gate. But when the start pulse, when when the output of the start pulse is fed to the gate. So after getting the start pulse from the input comparator, the gate is open. After the gate is open, whatever the pulses generated from the oscillator, that is passed through the gate and reach to the counter. The function of the counter is to counting the number of pulses reach to the counter. Reach to the counter. After that, there is a digital readout is connected here, in which it is shows how many pulses are being reached to the counter. It will give a digital readout. And here we can see that after getting, you can see or you can understand from the voltage to time conversion graph. So here the voltage, when the input voltage and the ramp voltage is equal, so here the start pulse is generated. And after getting the start pulse, the gate is open. The gate is open. So at the time the gate is open, the clock pulses which are generated from the oscillator, the pulses which are generated from the oscillator, that is passed. So these are the pulses which are being passed when the start pulse given to the gate, and after the gate is opened, the start pulse is passed through the gate. Okay. So now when it will be stopped? So it will be stopped when the ground comparator. So as a measure of a ramp voltage, so it is always measures slow when it is going towards the negative. So it will, so that's why it will compare to the ground also. So that ramp signal is also given to the ground comparator, which is compared to the 0 volt. When it is reached to the 0, when the ramp is reached to the 0 volt, then it will gives a stop pulse. It will gives a stop pulse. So after getting a stop pulse, the gate is closed. So here you can see also. So after it will equal to the 0, so it is giving a stop pulse. After that stop pulse, no pulses will be passed through the gate, as the gate is closed. Oscillator will generate the clock pulses, but it will not pass through the gate. Why? Because the gate is closed after getting a stop pulse, and the counter will not count at that time. That means there is no digital readout. Okay. So after that, now comes to the sample and multi-vibrator. This is the last block of the ramp type DVM. So the sample and multi-vibrator. So this is used to reset the ramp generator and the counter. So this is the function of the sample and multi-vibrator is used to reset the ramp generator and the counter. So this is the working of the ramp type DVM. So ramp type DVM is basically used to because this is named so. Why? Because the ramp signal is used to operate the voltage or to measure the voltage. That's why it is called the ramp type DVM. So DVM is your digital voltmeter. So in the digital voltmeter, the ramp type signal is used. That's why it is called ramp type digital voltmeter. So the advantage of using the ramp type DVM is it is easy to construct, and the cost factor is it came by, or it is having the low cost and easy to construct. So this is all about ramp type DVM. the next video I'm going to cover the topic digital multimeter. Thank you.